Hey, hey, Robert and Andreas. Alyssa here. Video letter 8. I got up this morning and I had this. I wrote out all of what I thought I should write to you, and I titled it "Meta Analysis: Sonic Pressure Sensors." And then I was just like, no, I still need to cover um, why I think this video letter is important. You guys are both from Germany, and you might know Martin Grunwald. And Martin Grunwald had a book in 2016 called Homo Hapticus. And it's only written in German. And when I wrote to him and I said, is this available in English so I can read it? He wrote back and said, no, but if you know an editor, let me know because I'd love to publish it in English. Okay, damn it. I don't know German. I thought seriously about trying to learn German so I could read his book. Um, but on one of our Swedish television shows, he was on talking about emotions, talking about the body, talking about the brain. And he had some very interesting viewpoints that I hadn't heard. And in Swedish television, programs are um, not edited. So if a French cooking show for my husband or Italian is on, then it will be in the native language and then Swedish subtitles on the bottom. And it's a great way to learn Swedish because I stop the video, I take the text and the subtitles, and I Google translate it, and then I can understand it. Now my Swedish is better, but for German, I had to do that because he spoke in German, and the Swedish subtitles were just like the text was mind boggling. So I think both of you probably know him, not because Germany is a small country, but because of what he does. And let me see, can I find? I think I can find a picture. Yep, found a picture of him. If you don't know him, then maybe the picture will jar your memory. So, yeah, Dr. Martin Grunewald. So on YouTube, here he is having an exclusive interview, and it's in German, and that's not a language that I understand, and it's taken me 10 years to understand Swedish, so I'm probably not going to learn German right now. But he is in the haptics laboratory for the Institute of Brain Research in the University of Leipzig. I'm going to ruin this. Leipzig. And before you had published information or written about, we have 250 million receptors all over the body picking up signals. Um, the first estimation was that we have about in our bindeväv or connective tissue, our fascia, our superficial fascia, our adipose tissue, I think is in there, deep fascia. Well, if we just have the fascia, it was about 100 million sensory receptors throughout the body. But then that was updated to include what Dr. Carla Stecco has laid out for for the human fascial system. And that was a mind boggling number, 250 million. So anyway, so to go on, what I'm trying to say about Dr. Grunwald is he's connecting exactly what I want to get across. And that is that we have a system all over our body, that the somatosensory system. And the somatosensory system is delivering to this human figure all sorts of information. Um, I did it better today on my email. So why don't I share my email? So where did my email go? So I just listened to this today on the TED stage, and you might not be familiar with Chloe, but if you are Australian, you probably would be, because she was the first autistic actress to play a role of an autistic person. And so August 2024 is when this was done in Sydney on this TED Talk. But she said, autism spectrum isn't what you think. And Chloe is very eloquent, and it's a written out script, as she says, and she's very open, and she's very precise. But she said the next day she might be a totally different person. So just definitely go have to listen to it. But she said, so how do we start to unlearn what we know and relearn what we need to know? And the answer, she said, is embarrassingly simple. Listen. So for a long time, autistic people haven't been listened to. And the thing is, I I've been reading some books, two of the same name, and all in her head. And it's crazy. Two separate books, two separate authors, all in her head. And this is by Elizabeth Coleman, doctor, and this is by Misty Pratt. And Misty Pratt is a journalist. And so it wasn't too long ago that who was it? Jennifer Bray, Brea. She did a video on Vimo because she has ME, myelitis, ME. I can't remember what ME stands for. Jennifer Bray. It's embarrassing that I would forget this because it was such an impactful documentary that she did. And ME is commonly known as chronic fatigue syndrome. So she recently, 2007, 15 maybe, she went to her doctor after having a virus after backpacking somewhere, and her husband got the same virus, but for some reason her body just did something different, and that was never linked to the virus. But the neurologist that she said it's all in your head. She had conversion disorder. So the basis of this is that I think that there's so much more we should be doing and talking about, considering the fact that, nope, hang on. Jennifer Bray's story is outstanding. Um, she did the Unrest film with her chronic fatigue syndrome, ME, uh, in the middle of it. And luckily, she's in remission. But the thing is, she doesn't know if anything will come back. But for her to be told by a neurologist that it's all in her head, um, it gives rise to the fact that my mom had some strong issues with depression. And it's not like cancer. When you tell somebody that you have cancer, there's an actual a little bit of a sorrow. Say to somebody that you have a broken leg, there's a little bit of a sorrow. I mean, it's physical. You can see it. But when you can't see it, like my mom's generalized anxiety disorder and her depression, then for some reason it's just not the same. The response from society, and that has to change. So when we talk about the somatosensory system here, what I wanted to do is just describe the reason I'm putting all of these things together is because, like Chloe says, we might have to just relearn what we thought we knew. Yeah. So I wonder if you're gonna, nope, 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 nope. So I wrote it out beautifully. I wrote out my thought process, and this is the nutshell. And so, video letter number 9 hopefully will do more of the meta analysis on where some of these sources came from, besides Martin Grunwald and uh, quite and some of the books I've been reading. But so here's the thing. So the sensory somatosensory system that's here with our 5 major senses is the foundation of the pyramid of learning. Now there's other senses, and there are some out there that say there's up to 33, 32 senses, like chemosense, and uh, the chemical sense is like wasabi. So if you're on an airplane and the air pressure is changed, then food doesn't taste the same. And then as a chef, chefs know that they can put in wasabi or something like yeah, mustard that has the chemical sensation that activates receptors in the nose. So if anybody eats wasabi, which is a wonderful Japanese product cuisine, then they'll all know that burning sensation that happens, and that's chemo sensation. So that's part of it. Also interoception, proprioception, and those probably are on the pyramid of learning on a different platform above the 5 major senses. But the somatosensory system is bringing in bucket brigades of information, and these bucket brigades are eventually sending these signals and transducing these signals onto the brain because they're afferent signals. And it's coming from a variety of information from multiple disparate sources. So, multiple different sources. And it's so important to have these different sources because these different sources couple. And when they couple, they synchronize. So, physical stimulation is neural entrainment. But here's the thing, the body is the one that has to behave. The body, after these are interpreted, then the body is behaving accordingly to the afferent signals. So hormones are released or not released. And that's physiology. Our blood pressure goes up. Maybe we're scared, and so our blood pressure goes up. Maybe we're scared and we just automatically pee. Maybe we're scared and we freeze, and we're all different. So that fight or flight experience is going to be different for everyone. But that is physiology. Psychology is the emotion, the thinking, and the thoughts. And that comes from the body. So when we talk about fascia is a sensory organ and the fascia system, that's what we'll get into a little bit with the next video. So this is why I think it's important to make sure that we know touch is a critical aspect. And where did I get this information? So you see my hat? Yes, yes. Griffin, Griffin. Griffin is a name of a hunting attack and signaling aircraft in the Swedish military. And Saab made it and have more information. But Griffin in English is translated to griffin, and it comes from the mythological creature that is part hawk and part lion. But for some reason, they don't use the word griffin, which is Swedish. So throughout this particular section, I'm going to talk about Griffin, the Josh Griffin. But yeah. So most of this information that I'm sharing with you now comes from Wikipedia, but then there's other sources too. So the cool thing is you can see these Wikipedia pictures, but this is a great aircraft. Oh, is it not going to blow it up? You. Boy, that takes a long time. Well, that wasn't such a good picture, was it? Anyway, so the Josh Gripen is a Swedish Air Force made by Saab. It has a canard wing design. You can see the wing design for short takeoff, and um, it can land uh, it can land very quickly, and it can take off extremely fast. Yeah, this is where we're going to go to. So the Swedish Air Force made it in 1996, and the Yak, that stands for the J, is air to air, and the attack is air to surface. Yak is also a hunter in Swedish, and then the S is for the reconnaissance, and that's the intelligence gathering that it's getting from wireless signals in the air. So Saab describes the Gripen is capable of instantly switching between roles at the push of a button. So the roles of the human pilot and the machine interface change in a great way, and they have a synchronization or a symbiosis, I would say. And the design of the aircraft is intentionally unstable because then they're using the digital software to maintain stability, um, remove a lot of the flight restrictions, which means it can take off on an aircraft carrier pretty easily, just straight up. And here in Sweden, there's air shows. And so if Håkan Olesen gets this video letter, then he's going to know because I'm sure he's been to a military base and seen the Joss Gripen 39. Something, and it just takes right off. So it's because of this intentionally unstable design, it improves maneuverability. Yeah, so that's Wikipedia, and that's the United Kingdom English. And it reduces drag, so it can also land. But here's the thing, it's the software, and the software is continuously updated. All the time, it's being updated. And that is just like our body. And our body has, in a sense, fusion sensors, sensor fusion, however you want to say it. But the software is taking in information, a multi-sensor. So just like our body has a somatosensory system with the eyes and the ears and the nose and the taste and the touch. So we can walk through the forest and we can feel a light breeze and we're feeling fine. But if for some reason we hear a crack of a stick and we know we're alone, we're going to be on a little bit more alert. So we have to use all of our senses in order to make good decisions. And based on previous experiences, whether Lisa Feldman Barrett is followed with her information or Holly Klein, who we talked about earlier from Scripps Research, then those previous experiences inform how we're going to behave, our physiology. Is our blood pressure going to go up? Are we going to have a sympathetic nervous system response and we're going to run? Or are we going to freeze? So um, if you go on Wikipedia for sensor fusion, it's combining multiple data sources such as video cameras, particularly in the Joss Gripen. Video cameras, which like us would be vision, Wi-Fi localization signals, so wireless communication, and it's doing these multiple pieces so it can have more accurate, more complete, and more dependable coupling and decision making, because as a result of multiple sources, it gets a clear picture. So they use the example here of stereoscopic vision. We have two eyes. And with our two eyes, we can calculate depth. And that's, it combines two-dimensional images from two cameras and slightly different viewpoints. So we have stereoscope vision with two eyes. And this particular aircraft also has stereoscope vision. So what else was I going to say that's cool about this? So it describes direct fusion. It describes heterogeneous, homogeneous sensors, soft sensors, history values of sensor data, and indirect fusion uses information sources like prior knowledge about the environment and human input. And right there, it's just going along with the same information that Lisa Feldman Barrett and Holly Klein have talked about. We have to use the prior information. And that's why as a child, when you saw pictures of my daughter, she learned eventually to eat on her own, and I don't have to spoon feed her anymore. And she's not as messy, and there's not blueberry all around her mouth because all those prior experiences taught her, oh, this is how I do it. So we can train the proprioception system, and we can train these multi-sensors. And if we lose these multi-sensors, then we have problems negotiating movement. We have problems with our thought patterns as well. I can tell you in a crowded room, my hearing's not as good as it once used to. Well, my hearing's not as good. And in a crowded room, when the sound is all over the place and there's not acoustic baffles that are dampening it, it's very hard for me to make out conversation, and especially in Swedish. English I can usually make out, but Swedish I really have to be very close to the person to understand. And Jaap van der Wald, when he was in Stockholm, he was giving a 5-day class on the embryo. And so the American, always Swedish American, raised her hand and asked a question. And eventually he rolled his eyes and, oh, yeah. Okay. He answered my questions, but he also is harder of hearing. So I can only imagine that, first of all, he has a thought, he wants to get it through, he wants to not be interrupted. And here's this person in the back always raising her hand. So it was quite annoying. But in 5 days, he covered all the information. So embryo brings me back to Josh Gripen. The Gripen is an aircraft. And like Yuval Harari, we talked about Professor Harari earlier in video 1 or 2, but he was in China promoting his book Nexus, and Professor Harari describes the difference between AI and humans. And the thing is, AI can do computations faster, and it can take information from multiple sources for AI to generate answers. But what it can't do is emotion. And that is, I think, what we overlook, because if we're not touched, we know now from Håkon Olesen, Åke Valboy, and Francis McClone that the slow touch system is super important for how we behave, how we think, how we feel, and that is all part of this somatosensory system. I'm not saying it's a cure. I'm just saying early interventions could possibly help. Because what happens when we lose our senses? What happens when we lose our senses? Ian Waterman is in this book, and quite a few others, because our information is going up to the brain. So, what happens when we lose corpuscles? Mechanosensors. We don't have as much information coming in. And without the proper amount of information, those predictions that the brain makes might have more mistakes. Because, like this griffin, it's multiple sources of information sending signals all at once so it can be filtered through for the right interpretation, for the right decision making or ideal. And when we don't have enough information, we have misinformation or disinformation, then good decisions are more difficult and mistakes can be made. So whether that affects physiology or psychology probably is up to the individual and the individual's body. So Martin Grunwald, because I couldn't find Homo hapticus, Homo haptics in book that's written in German, I found this one. This is his textbook that he edited. And it's really kind of funny because it's printed upside down, inside out. But on a certain page, learn learning learning effects in haptic perception. So the ability to learn changes over time. So older people have a harder time learning. And here's a page that's not written on. Um, as I said, my husband hates it, but learning effects in haptic perception. So haptic, what is haptic? Touch, touch. Just replace it with touch. So why are these sensations, why why is our perception and our ability to learn things different? I mean, why is it easier to learn a violin when we're 5 years old rather than 52? And this is the same sort of thing. Why was it easier for my daughter at 8 years old to learn Swedish in 3 months, and it took me at 43 years old 10 years? Yeah, it just might have to do with the amount of receptors that we have. So, sensory receptors. So, in Martin's book, uh, chapter 6, Anatomy of Receptors, yeah, I write, page 90, here at the bottom, yes, here at the bottom, it's about Meissner corpuscles. And they write Meissner corpuscles are oval in shape. Yes, yes, yes. Meissner corpuscles are found below the epidermal grooves, below the fingertips. Epidermal grooves is fingertips. Okay, so they're found below the fingertips and are thus more superficially located than the intraepidermal Merkel cell receptors at the bottom of the glandular ridges. Yeah, 1 square millimeter. So 1 square millimeter, for you guys know millimeters, but it's the tip of a pencil. So the tip of a pencil of skin can contain up to 24 Meissner corpuscles. However, this number decreases with age to about 6 per square millimeter in 70 to 84-year-old humans. Now, how does that affect 70 and 80-year-olds with grip strength if they can't feel, just like the woman that had her fingers numbed? It took her 20 seconds extra to just light a match. So if this is just one receptor and it's reduced down from 24 Meissner corpuscles in 1 square millimeter down to 6 in 1 square millimeter over the course of time, then we really have a problem that we have to start facing, because possibly we can keep training these just like you go to the gym and you work out, but movement and having a hands-on therapy really is helpful for this, which is connected to this. which is physiology and psychology. Yeah. So I have a paper here from a guy in Spain. I did write to him and he said he would get back to me. Is he Spain or Portugal? Yeah, he's Spain. So, oh, Jose A. Vega. And oh, he's in Santiago, Chile, and he is in the Department of Morphology and Biology, Cellular Morphology and Biology in Spain. So I did write to him, and he said that he was going on a trip and he would get back to me, but he didn't. But I know those things happen. At least he wrote back. That was cool. But he says decline of tactile sensation associated with aging depends on modifications in the skin and both central and peripheral nervous system. The number of Meissner corpuscles and Merkel cells decreased progressively with aging. The Meissner corpuscles were smaller and were found in the oldest subjects, the smaller ones. Reduced expression of PZO2 in the axon of the Meissner corpuscles and the Merkel cells was also observed in subjects, as well as a decline in BDNF, brain-derived neurotrophic system. So if we're not having this hormone in our body that's helping to produce ideas and we get when we exercise, how is a person that's 70 and 80 years old going to be able to maintain that? Well, usually in America, in the United States, we're given a drug. But but these morphological and size changes happens as we age, and this is probably what we need to understand, because there's also a decrease in the density, the population, the number, and mechanoprotein PZO2 and neurotrophic systems are reduced in aged corpuscles. Taken together, these alterations might explain part of the impairment of the somatosensory associated with aging. This is just one of those, it's just a small little tidbit of information. It's a great. I am winding down. But Mark Rutland was nice enough to email me back because I emailed him and I wanted to ask him some questions about this particular paper, mechanisms of tactile sensory deterioration amongst the elderly. So Mark Rutland, man, he's with the Rise Research Institute in Stockholm, Sweden. He is also with the Royal Institute of Surface and Corrosion Science in Stockholm, Sweden. And I think in another paper that I have of his, he works in France and Australia. I mean, this guy gets around. He's a chemistry professor and quite smart. However, he talks about this particular situation with tactile stimulation deteriorating. Mechanical restoration of tactile ability has the potential to increase the quality of life in the elderly. So, how do we take a pill for not having a tactile sensory system? I mean, when we're younger, we can relearn things, and people relearn things all the time. I want to share with you Mandy Harvey, but if we're older, how does this happen? So early interventions so that we can train these receptors not to go away, and maybe the skin won't be as frail either. But the human hands and fingers are used for active exploration of our surroundings and for grasping our objects. And there are primary tactile probes. Fingertips interact and are thus highly relevant for understanding tactile perception. He's got a great paper, so feel free. He's got some other papers about molecular weight of hyaluronan and tri tribology, so rubbing systems and how systems rub together. Fantastic chemistry. But there's people all over the place that are trying to change this. So we all, well, most of us know our Don Papaputa, the guy. And this was a Swedish television program. So he's the Nobel Prize winner in medicine, 2021. And I did this for a class that I had. And so therefore the screen is in Swedish. And he says, I am interested in we, how we interpret pressure. And pressure happens in many different cells. And we're not talking about that in 80 bug crates, interoception. We're not talking about these individual cells and well, how individual cells send up information in the bucket brigade, but it's from multiple sources. But we do have quite a few people that are changing paradigms. And then Lisa Feldman Barrett, who was on the TED stage, and she talks about so many awesome things. And Lisa Feldman Barrett, this is also in Swedish. You are not at the mercy of your emotions. Your brain creates them. She talks about that prediction system. So emotions are based on previous things, I think. And Anders Hansen here. Anders Hansen is a psychiatrist, doctor in Sweden. And he's written many things about emotion, many things about the brain. And we might just give a little too much credit to the brain. The peripheral nervous system is really responsible for behavior. The body. So the body makes decisions without conscious thought. It's our biology, it's our physiology, and it's our psychology. Small things give information. And small things, everything is small. Look at the Pizio 1 and 2. Even Ardam Pataputians talked about that and how one Pizio channel opens up and like a million ions rush through in seconds. And that's not just one. This happens in multiple areas to get a collection of information so that the transmembrane around the cell can make a chemical, can make a reaction. So we need a lot of Pizios. And they have found out there was one woman that was born without, they did gene sequencing, and she was born without Pizio. 2. I may have been in the middle of an idea. It was about the woman that was born without PZO2 and how she overcame that. But now that I'm on this particular thing with Ardam Pataputian, this was given in 2018. It was before the Nobel Prize was given, but he's chatting about these ion channels. And the ion channels open rapid conduction of 10 million ions a second. Ions flow into a cell and change electrical property of the cell, the voltage. Electrical impulse through the neuron. Message travels to the neuron to neuron into the brain. So he says it's like a light switch. And the thing is, this one channel, there's thousands of them all around, and they sense pressure. I have a great video from Alex Chesler. I wanted to show you that. I'll show you Alex Chesler's video here in a little bit, but first let's go back to Ardam Papaputu. Oh no. Screwed up. Okay. So again, I can't show video um, because there's copyright issues, but here Ardon Hataputian at the 2018 lecture at Scripps, he is talking about this particular researcher can stretch, she can record from the neurons firing, and she can go into the muscle and Katie Wilkinson and stretch. And while it's stretching, she can record from the neuron firing. And this is a really cool in time sort of thing, but the everyday person doesn't have this. But this is the person, and I can't show the video, which is really too bad. But you can go at the same point at 30 minutes and you can see for yourself. But this particular individual is a university student. I think that she is an engineering student as well. She had no idea that when she was blindfolded, she couldn't find her nose. Her sense of proprioception is not there. But because she developed her sense of vision so well, she's been able to overcome that. And she didn't even know that she was deficient in human PGO2 ion channels. But her proprioception, without the use of vision, she cannot walk in a straight line. So she's here in this harness because they blindfolded her and they want her to walk a straight line and she cannot do it. So the thing is, when Ardon gives this lecture, it's at 13 minutes and 33 seconds. 13 minutes, 30. Oh, I'm not going to find it. But around 13 minutes, I believe he says, that people in this situation will have to have their genes tested. And basically, these people don't have movement disorders. They have sensory processing disorder, sensory processing deficiency. It's not a movement disorder. And that's the takeaway from this. And now you get to see Alex. Now you get to see the video from Alex Chesler. This is on YouTube, A Gene for Our Sixth Sense. And so because it's a recording of a recording, it's not, it's the sound quality is not good. Just read the text and watch it. Okay, here it goes.
Which is sort of, you can imagine being sort of opened up. And that opening allows the cell to know that something's happening by allowing ions to flow into it. So for instance, if someone presses on your hand, and that your skin starts to deform, all of that skin is stretching around that thing, it's deforming your hand. And what this molecule is doing is it's sitting in the neurons in your hand. And as those forces start stretching your skin apart, this molecule also gets stretched apart. You can imagine if somebody came in.
Oh, fantastic information, isn't it? Yes. And there is one more piece of paper that I thought was interesting to share. And that happens to come in because it's about scoliosis. It's about scoliosis, and I have a client with scoliosis, so I found it very, very interesting. And this is November of 2016, and this is one of those things. This is good research, and the problem is, does anybody in the neuro world know about this when they're dealing with somebody with scoliosis? Is there a reason that they're doing surgical interventions with somebody with scoliosis and then taking the hardware out years later and only to have the spine curve again? By ALEC, by meaning two and ALEC alleles. So the loss of proprioception related PGO2. And then this is causing problems with muscular atrophy, and scoliosis. And it's a great paper. It's just amazing. So I thought I had a couple other things, but yeah. maybe it's not a movement disorder or a spine disorder. Maybe it's lack of physios. So when you relax something, you have a problem. You gave me permission to use this. And this is a great picture that I've used so many times to explain touch. And thank you very much. The artist is T. Lexi, and you gave me permission to use this in one of your emails. And I think I might have that spelling wrong. I'm so sorry. Sorry, because your friend did this picture. But when all of these receptors are listening, when all of them, like the hand of Alex Chesler, said that, he's done research with Karsten Bonemann, which is, I believe, German, and he's in NIH, along with Alexander Chesler. So when this happens to our skin, anywhere, all of these little fish, they're listening, and it's a sonic pressure. So we'll get into that the next. This is a long video. Gotta go. So go. Here you go.